flash point and flammable explosive limit. Okay, what is flash point? Okay, flash point is the lowest temperature at which a flammable liquid gives off enough vapor to form an ignitable mixture with air. So flash point is the lowest temperature where ignition could happen. Okay, in other words, okay, this is the lowest temperature. Okay, what is the flash point? That's the lowest temperature that form an ignition. Okay, when there is a mixture with air. So there are few definition of limits. Okay, there are UFL, LFL, UEL, and LEL. So actually, what is UFL? UFL is the upper flammable limit. Okay, it also have a upper explosive limit. Okay, so UFL is the definition and the terms used for flammable material. Okay, while UEL is for explosive material. Okay, so UFL, you have also UEL. Okay, flammable and explosive limit. Okay, then you have also LFL and LEL. So LFL is for lower flammable limit, while LEL for lower explosive limit. So what is the function of UFL, LFL, UL, and LEL? So what is the function of this upper and lower limits? Okay, so upper and lower limit will determine whether the mixture will burn or not. Okay, so the mixture will not burn if the composition is lower than LFL or higher than UFL, meaning that the mixture only burn in between the LFL and UFL. Okay, so you have lower limit, upper limit. So in the middle of lower and upper limit, okay, in the middle of lower and upper limit, okay, the mixture or the ignition could happen. Okay, it's either flammable or explosive material. Okay, this is a burnabilities for some of flammable liquids. As you can see, this is a gasoline, acetone, ethyl alcohol, methyl alcohol, and carbon disulfide. Okay, so this is the lower flammable limit. Okay, because we talk about flammability. So lower flammable limit, LFL, these are the LFL for each of these material. Then you also have the upper limit. Okay, upper flammable limit, UFL, for gasoline, acetone, ethyl alcohol, methyl alcohol, and also carbon disulfide. Okay, so the region upper than UFL, okay, will not burn. So as to the lower, okay, lower than this LFL. So only the mixture between UFL and LFL and UFL will burn. So from this graph, okay, or from this figure, you can see that carbon disulfide has a large flammability limits. Okay, so it will burn under a large variant of mixture. Okay, so another example is for gasoline. Okay, concentration vapors in excess of 7.6. Okay, this is 7.6. Okay, so the concentration, the mixture is too rich and it will not burn. Okay, while the concentration before, the concentration vapors below 1.4% also will not burn because it's too lean. There is not much of gasoline. Okay. Okay, that's the UFL upper region. It's too rich to ignite. And then the lower flammable region. Okay, under the LFL, that's the region where the ignition also failed to happen, okay, because it's too lean. Okay, this is a summary of what we can summarize from this figure. There is a broad and dangerous burnability range. Alright, this is the relationship between various flammability properties. As you can see, okay, this is the concentration of flammable vapor. Okay, the same like this. Okay, flammable vapor, but in terms of concentration, okay, this one we talk about limit. Okay, flammability limit in percent. Okay, this is the concentration of flammable vapor. Then you have your flash point. Okay, remember what is the definition of flash point? Okay, so this is the flash point temperature. Then you have your auto ignition temperature. Okay, we will look further what is auto ignition temperature in few next video. Okay, so this is the temperature versus concentration. You have flash point, auto ignition, then this is the curve. Okay, under this curve, okay, you have your flash point. So this is the region of your LFL. Okay, this is the region of your lower flammability limit. Okay, so remember, anything below this concentration of LFL will not burn. Okay, while you also have your UFL, upper flammability limit. Okay, anything above this UFL also is not flammable. Okay, so this is the saturation vapor pressure curve. So only this region will involve in flammability. Okay, only this region. Then, okay, remember you have your auto ignition temperature, AIT. Anything above this region, okay, this is what we call as auto ignition region. Okay, however, okay, for now, our aim or our focus is on this region, flammable region. Okay, so only concentration of flammable vapor in this region will involve in fire. So through this LFL and UFL limits, okay, all the materials can be classified based on their class. Okay, based on their class. So these classes, okay, will be determined through their flash point. Okay, so you have your flammable and also combustible material. Okay, so this is the classification of flammable and combustible liquids. Okay, with boiling points of 100 Fahrenheit. So you have your class 1A, class 1B, 1C, and then you have your class 2 liquids before you have your class 3. Okay, so in class 1 you have 3 different classes of class 1. Okay, you have class 1A, class 1B, and also class 1C. Okay, then you have your class 2 liquids, and also class 3. Okay, class 3 have 2 different groups, class 3A and class 3B. So all these classes have been separated by their flash points. Okay, by their flash point and also by their boiling points. Okay, because class 1A and class 1B liquids have same flash points, okay, but different boiling points. Okay, so all these classes, okay, all the material can be classified based on this graph. Okay, so this is how we can define all the classes, class 1A, B, C, 2, and AB. So you have your flash point, boiling point, okay, and also what is the example of this classes. Okay, only class 1A and B have been classified according to flash point and boiling point. Okay, class C only depend on class C. 1C, 2, 3A and B have been classified based on their flash point. Alright. So there are a lot of agencies, okay, that have their own definition. Okay, they have their own definition. However, all of these agency, okay, use flash point as the flammability criteria. Okay, it's either EPA, NFPA, or DOT, Department of Transportation, Protection Agency, and also Fire Protection Agency, still depend on flash point as their flammability criteria. That's why when we have our classification, okay, our flammable and combustible liquids, okay, this classification is based on flash points. In next video, we will look further what is the characteristic of the liquids and vapor for this flammable material.